Hello and welcome to this video on Vamp, a tube-driven multimode filter with added VCA and saturation with serious bite and sharp fangs. Here's what's to come in the video. This video is sponsored by Apollo View Modular. In this video, we'll go through lots of ways of using filters in a modular system, coupled with extra tips and tricks for saturation of a variety of sources and ways to make musical use of VCAs. Vamp is an 8HP multimode filter with added tube input stage, a tube resonance path, a pre or post routable vintage VCA design, some smart normaling of CV inputs, and a freeway off, soft and hard clipping output stage. The filter topology is based on the late 70s Korg design filters you find in the early MS-20 and MS-10. However, in Vamp it's a single filter unit with switchable low band and high pass modes. Apollo View have created a filter that leans on that non-linear character, adds even more character, while also designing in modern control and stable tracking options. There's a great write-up from Apollo View that I'll link below that outlines all of this. So let's go through the features. And we start with our main inputs, and depending on the position of the flow switch, if this is up, it first hits this vintage VCA design with gain CV and gain CV attenuverter for the gain CV input. And that allows you to vary and CV control the input level and the amount of tube saturation at the input stage. If that flow switch is down, this input goes straight into the tube with a preset amount of tube character because that VCA is routed after the filter. And it's set so that with an input of a 10 volt peak to peak typical VCO wave, there's a bit of tube saturation and you can vary that externally by adjusting the input level. So whether you go through the VCA at the start of the module or not, your input goes into this tube input stage and you're into that core of the filter. We have a freak control for frequency, and that has its own CV input and CV input attenuverter, and that will normal from that gain CV if you don't plug anything in. And there's also a stable, unattenuated volt per octave input for pitch tracking across all of the modes. The filter core itself changes modes on this mode switch, and that goes from low pass when facing down, band pass in the middle, and high pass when that switch is up. Res controls the resonance of the filter, and that resonance is actually in the tube path here in that triode in the tube. That has a CV input and CV input attenuverter again, and that is normaled from the freak input to the left of it. So a single input to the gain here can normal right across all of these CVs. And if that flow switch is down, this is where that VCA appears at the end of the signal path. You've gone through the tube input stage, your mode switching, your filter controls and your resonance, and then you have the VCA at the output. That finally hits the Fangs, which is an output clipping stage, and that's off when the switch is up. In the middle, that's a 4-stage progressive diode ladder soft clipper, and going from the middle to the bottom, that's a hard clipper for precision limiting with that switch down. As always, the patches in the video, and there's plenty of patches in this one, the patches are noted in the timing index and chapter markings in the video description. Do skip around as you like, give these patches a go with Vamp and with other module combos, but up first, like any filter demo, let's sweep some knobs around with a low pitch saw wave and hear how it sounds. Without further ado, let's dive in. So here's a little kind of love letter to the bandpass, because if a bandpass could kill, I'm sure Vamp would be one of those bandpasses. Now if I mute the kick, this is the straight output from Vamp with no processing, and these bits of modulation I have in this switch so I can mute them. I have a sequence playing on the oscillator. It's the pulse output straight into Vamp. I hope you're all kind of rocking your mouth open like I am. So building the modulation back up, green trace green cables into Freak here. Just a basic envelope. I'm using the volt per octave as a second frequency input. It's unattenuated, but that's fine here. And the blue tracing cables is some stepped random. So as I combine them, I get this clocked stepped random, plus the nice twangy envelope on top. I have some stepped random red tracing cables to resonance. Less prominent than the frequency stepped random, but they work in tandem, just kind of throwing this around randomly on the grid, or on the clock rather. And then I'm using the Attenuverter for the gain with a quarter note envelope to do my side chaining. So hopefully you can hear that dip, that pump, as I bring my kick back in the mix. Without needing offsets and inverters for that envelope, I can just attenuvert an envelope right on that gain. The flow is set so the gain is before the filter, so we're kind of side chaining into more tube kind of compression and saturation before the filter stage. I have the Fangs set to soft clip. Here it is clean. We could hard clip. Which works really well too. I've got a real kind of soft spot for pushing into the tube and then soft clipping. So here we're looking at Vamp as a pseudo low-pass gate, coupling its VCA with its low-pass filtering to give a low-pass gate-like response, even just on this sine wave. Vamp's just giving that kind of right musical amount of harmonics. And this is my input waveform, a sine wave. Now, by coupling level, so turning down that gain and the low pass filter's frequency there, by coupling filtering with level, so as the sound gets quieter, it also gets duller, which is how sounds in the real world work, we have a low pass gate-like behaviour. So by sending in some envelopes here, gain CV is already up full, let's turn up frequency. And one trick I like to do to get nice low pass behaviours from things that aren't actually low pass gates is to mix both a longer decay envelope and a very short percussive one to get this kind of behaviour we can see here on the yellow trace, and that's coming in on the yellow cables to gain CV, which normals right across, so it's also modulating the frequency. I'm mixing those envelopes in Curiouser, and again yellow cables coming into gain, and we can think of a low pass gate, say a vactral low pass gate, that might have a bit of bleed, so if you actually push up the gain, we have an offset starting position, and with the flow before the input stage here, the peak of these envelopes, the gain CV up full, just going to be pushing that sine into the tube, and that's what's giving us this character. Let's add some soft clipping right at the output stage, mid position on the Fangs switch, and you can hear we've got a musical pseudo low pass gate. I'm going to bring the effects in just for fun here. If I go for a more complex wave on the way in, that combination of some folding into that input stage that's hitting that tube for some nice shaping, soft clip on the output, and even with the folding add some linear FM, so really aggressive, complex sound. So Vamp there as your kind of output VCA and VCF, or pseudo low pass gate. There's tons of character, which is really nice behaviour. So here I'm using Vamp as a drum bus for tube saturation, a little bit of additional soft clipping, a resonant high pass bass boost, an accent pattern, and for some performance sweeps that return perfectly back to where I've got that bass boost set. Let's clean everything up and go from the beginning of the patch. Now the first thing is having that flow switch up puts the VCA before the tube input stage and filter. So rather than it being after, where we have a kind of preset input level amount, a preset amount of clipping into the tube, we can actually really push into it or clean things up. And then sticking with the idea of saturation, we have the Fangs, the output clipping, soft clipping in the middle. Gives a bit of a kind of woolly, warm fuzz to the kick, or hard clipping all the way down. Good when you want much thicker, harder distortion sounds. I like the soft clipping in this case. A few of you may know, as I've done this in several videos before, you can use a high pass filter like a bass boost, and this is great for drums. If I turn up the resonance and just sweep, if I add a lot of resonance, you can hear that's oscillating or very close to, and then if we use the freak control, the frequency to just fine tune to that low bass fundamental in the kick drum, you can really pull out the subs. So turning the res down, it's kind of so limp in comparison, and then cranking it up, we're adding resonance right at that fundamental frequency of the kick. So input tube saturation, resonant high pass bass boost, and then some output soft clipping. I think it's a great sound for a drum mix. But then I thought, well, I'll add a performance sweep because it's really nice to sweep that frequency come back down again. But each time I do that, I'm going to lose that kind of fine tuning I've done. To boost that bass on the kick. So I thought, well, I'll use a macro controller here, or rather an offset generator, and create a macro control. If I remove my effects, what this is doing, patching into Freak here, I've got Freak turned up on its CV attenuversion and resonance turned down, so that sweep will sweep the frequency up but bring the resonance down. Sliding back down performatively right to where that bass boost is set. Now on top of that, I have this opening the decay on my hi-hats and turning up a VCA for my reverb send. And then finally, I have a quarter note accent pattern that hopefully you can see on this LED cable that I'm going to patch into the gain. So if I back off just to clean up a bit, and then with the gain CV up, it's going to push more level on the quarter notes with an envelope. Equally, if I invert that CV, got this really cool pumpy sidechain effect. But we've of course lost the kick. Let's push more level in. So we're accenting quarter notes. A resonant high pass is bass boosting. We're pushing into tube saturation, soft clipping the output, and we have that performance style. Sweep that keeps our controls intact and influences the rest of the patch. So here we're using Vamp as a voice, and it's a pinged filter. I'm pinging the filter here. Really nice sharp transients, good percussive notes, with a bit of FM, some dynamics coming from a sequence and some effects. I'll remove the effects, and I'll just pull the modulation for now. And let's just go through how you ping a filter, and what is a filter ping. Well, a filter ping is to actually input a trigger to the audio input of your filter, and to turn the resonance up just below oscillation. So as I turn this up, even if I remove that trigger, you can hear it's oscillating. And if I go just below that point, and then start to patch in a trigger to the input, this is a filter ping. And it's interesting when playing with pinging filters, because different filter modes, like a high pass there, will let more of that trigger through. We're going to get a sharper, brighter, kind of ticking, percussive sound. The low pass will let a bit of thud and rumble. And I find a band pass is often the right one to use for me. And if I add volt proactive tracking to the volt proactive input here, I'm then going to add this sequence to gain, back the gain off slightly. So I'm pinging it with a consistent trigger level, but I'm varying the gain after the pinged filter. It's like running this through an external VCA after it, to give some dynamic movement. And the amount of that is controlled on the gain CV. And I have an oscillator here. I'm going to patch into frequency. And just add a touch of FM. So the sine wave is coming into this to FM it. This is tracking pitch, but if it wasn't, you could have a static oscillator adding a bit of FM there. So try Vamp and other filters, giving them a ping by sending a trigger. That could just be a really short envelope if you don't have a specific trigger here, to the input of your filter, set the resonance just below oscillation, and playing around with pitch tracking and FM, there's a range of interesting results to be had. So here I'm treating Vamp like a WAVESHAPER, taking a basic waveform, a triangle input in this case, adding some modulation, resonance, filtering, gain and clipping to create an interesting wave shape, and then getting that to track along with the oscillator like a WAVESHAPER. If I stop my sequence and pull all the modulation here, and then go to listening to just this output droning in the mixer, we have an interesting wave shape on that blue trace there compared to the triangle coming in. Now, backing things off, this is simply distorting and filtering that triangle wave. We could play around with if we're pushing into the tube or placing that VCA after the tube input and the filtering, adding resonant peaks to the sound. And as this will self-oscillate, you can almost add like a secondary oscillator overtones, and they kind of lock in. So if we consider this kind of wave shaped as opposed to filters, and really a filter is a wave shaper, a saturator is a wave shaper anyway, you might want to animate this and get it moving. So if we take LFOs, just 3 different LFOs, to res, to freak, and to gain. If I then just start a sequence, I have this nice, really characterful wave shape, but the wave shape isn't going to be consistent anymore. That sound, even if we remove, say, the modulation, you can hear it's almost like a static resonator-like sound. If I patch a copy of the volt per octave to Vamp, it will track the same pitch that the oscillator providing the triangle input does. And we have a consistent wave shape that really sounds very different now this pattern's playing, without that pitch tracking, and with. So we can then add some animation again. And it's a totally different, unique, interesting sound. You can then articulate that however you would another wave shape. Here I have it playing in 2 low pass gates, just pinging in stereo. So consider your saturators, filters, resonance, lots of resonance in this case, resonant peaks as wave shapers to shape waveforms, get them volt per octave pitch tracking, and then articulate them in interesting ways. And I really love that nice musical, rich, unique sound that this kind of approach gives. So I just started unpatching the previous patch and thought to myself, if Vamp isn't a filter and it's a wave shaper, what does audio rate modulation sound like? What does just using one kind of basic oscillator, again this is a triangle coming in and this blue trace out of Vamp, what if we patch other waveforms in and modulate the kind of whole thing with itself, or modulate the oscillator with itself? So if I take another waveform out here and say patch into gain so it normals across, there's a load of different waveforms, and these attenuverters are really handy. Let's try a different wave. Feels like you're really getting in, crafting some pretty unique shapes. So this is a triangle to the input, a saw wave to gain, normaling across to modulate. If I start the sequence, both Vamp and my oscillator will play the same volt per octave pattern. Without that tracking, it's like a static effect, which is quite cool, but actually getting it pitch tracking, like a consistent wave shaper for your oscillators. Wonder what happens if I say patch the sub out into frequency. Ooh, there we go. Again, a bit more Vamp as a wave shaper, with some other oscillator waves patched in for modulation this time. And again, treating that like a kind of complex oscillator output through other things, low pass gates, VCAs, wherever you want to patch it. A unique tube wave shaper. And I realise I'm kind of really hammering Vamp as not a filter but a wave shaper, but it is a way that I really like working. So stripping everything back here, I have a saw wave from my oscillator into Vamp, and Vamp coming out into a VCA, which we'll come to some nice mixing tricks with later. There's lots of kind of tips and patches here, so I'll kind of sub-timing index chapter mark them down below if you'd like to skip around. Let's just go from the beginning here. Saw wave into Vamp and the output. No modulation of Vamp currently. And just the character of it is just kind of oozing for some acidic, kind of TB303 style lines. Especially with a bit more gain. And let's start by adding my main envelope, this green trace and green cable. And instead of going into the main CV input here, I'm going into volt per octave. And that's because I want the normaling just to save a multiple or a split cable to create an accent pattern later. So using the volt per octave input, I'm attenuating here on IOU, so any external attenuator. Envelope to frequency. I'm going to use this blue trace as an accent pattern. Now that comes into gain, but gain normals to frequency, so every time this envelope plays, which is less frequent than the main one, we can add more level and open that filter that bit more. So if I use that, you can hear it's not playing as regularly as that main envelope was. So I'll start with the gain somewhere just over halfway. And hopefully you can hear that's pushing more level, more saturation, that low end's kind of blooming with tube saturation. And then at the same time, let's make the filter brighter. And doing that while we mix in some of the main envelope. Hopefully you can hear we've got this dynamic kind of two-layer of modulation going on, one of which is blooming into more saturation and more level. Now one other trick here, and I'll back off all the modulation. I have the sub out of my oscillator into resonance, and this is a really nice way of making the filter more resonant, but also imparting a kind of sub-octave overtone or undertone. So with that modulation, I can actually back resonance off. So you've now got this kind of sense of the sub. So adding in the main envelope, patching back in the accent. We're still sidechaining there in the mixer. All that kind of acid just from the saw wave, an accent pattern, and the sub modulating resonance. But a nice extension over this kind of low pass acid sound is to actually go to a band pass, which obviously loses the low end but just has this great raspy sound. And to get some low end back in, this going through this VCA mixer here, I have the triangle on this orange cable that's a bypassing vamp. This is a bit like in, say, a soft synth where you can route a sub or a sine straight to the output. This is a triangle to my output section here, this output, and then blending in the bandpassed saw wave. I feel like I get the best of both. I get the weight, kind of consistent warmth on the low end of the triangle, and all that rasp and character of the bandpass. So here we're using Vamp melodically like a full voice. Now there's a pretty extreme kind of twangy sound going on, which is from FM from the oscillator here into the frequency CV input. We have a few nice ways of controlling this like a voice. It will self-oscillate before you turn up res fully there. You get a clean sine around 3 o'clock. With the flow switch down, so the gain of VCA control is after the filtering, so after this self-oscillation, you can push into just controlling this cleanly, which is why an envelope here works like a kind of oscillator into VCA type synth voice, but you can push into soft clipping, enveloping into that bit of shaping, has a really lovely, warm kind of drive to it. You can hard clip with Fangs all the way down. Bit fizzier. Let's stick with soft clipping. And if we go back clean, and again just turn this up, turning resonance up, you can actually clip the tube resonance feedback path. The tube is part of that resonance in the filter core. So there's a slight pitch drift. It pushes into an impure sine. It's not that pure self-oscillating filter sound anymore. And that into some clipping. So set up soft clipping, mid position here. Gives a lovely colour, pushing into some drive. And there's a slight wave shape change on those notes. It pushes into that soft clipping. Now with nothing in here, let's patch our oscillator back in. I'm playing around with the depth of modulation and the tuning. Really does work well as a voice. Again, that's volt per octave to the volt per octave input, resonance, which is a cleaner sine around 3 o'clock, where it starts to self-oscillate, but pushing into some resonance clipping and shaping in the tube, soft clipping the output, enveloping the gain after that oscillation, and some FM from an oscillator for further shaping, and that's Vamp as a voice. So here I'm using Vamp as a kick, and with the wave shaping options, that bit of clipping, and the CV control, I think it makes for a really great flexible kick with a couple of envelopes. And this is building on from the idea of it being a voice, where we make this oscillate to the resonance up high, control that level with the flow after, so the VCAs after the oscillating filter. And then we can play around, frequency modulate and amplitude modulate to create a kick. Now the other sounds I'll just mute here, and I'll get these two envelopes playing the same rhythm, and we'll just go through setting up a kick. Now cancelling out the CV and just turning this up. Like before, the resonance can be cleaner. Let's make sure we're clean here too. I'm pushing to a bit more shaping. Let's keep this clean. And I'm using the green trace with a hold at the top, just for a bit more energy and body in the sound, to the VCA. The flow is set afterwards, so it's after this oscillating filter. If I turn down the gain, and then turn up the effect of this envelope, this just works like a note. Now we could, if I remove this signal, let this normal through to the frequency. But I never like the result of making a kick drum where the same envelope pitch modulates it as actually control its amplitude, so I have a thinner, faster decay envelope here. And that's your basic kick recipe. A sine wave, which an oscillating filter does really well, or in this case a more interesting tube-shaped sine wave, into a VCA with some frequency modulation, and if we tune down to a kick range, now you'll need some headphones or some big speakers on. With a good clean kick. Now we can turn on the fangs into the mid position for some soft clipping, which you can then back off the amount of drive you're adding just by bringing back that gain CV. You could push into hard clipping. I'm going to stick with soft clipping, but just back off, so we're just kind of touching it. Now I then have a little gate signal that's just coming up on the first step in the bar to the resonance, and that's to push from this cleaner sine into more of that shaping, like an accent at the start of the bar. So as I bring that up, hopefully you can hear 1, 2, 3, 4, 1, 2, 3, 4. I'm just going to dial that in as well. And then because we have different signals to our amplitude, to our gain CV, to the frequency, we can play around with different rhythms. So on my sequencer, if I change the pattern, the green trace here to the amplitude, you can see, and hopefully hear, if you can hear this low end, dum ba dum bum, 1, 2, dum ba dum bum. We've got this extra rhythm in the low end. Works like a kind of hybrid bass and kick drum voice. If we then look at our envelope to frequency, and I start adding in some steps here, as that first note decays down, I'm adding in extra envelopes here, getting into this kind of techno rumble, techno rolling kick type effect. So the main hits play together. There's extras that don't play together, either to the frequency or to the amplitude, for extra low end or little kind of percussive attacks, pushing that gain CV up higher, harder into this soft clipping. Other drums back in. That's how to patch a kick, and how we can go that bit further with Vamp being a kick. So two things that John Mark from Apollo View mentioned as really enjoying with Vamp and things for me to try was using a PWM saw wave as the input and enjoying that resonance character kind of working into these different peaks of pulses in the waveform, and then also to use heavy resonance into hard clipping. And let's get that PWM saw modulating, and the PWM saw has its history and origins in the Roland Alpha Juno. It's a combination of a saw wave, it's maybe a bit easier to see with the PWM up full there, you can see that rising ramp, a saw and a PWM pulse. So if I add an LFO to a PWM on the oscillator, these resonance peaks really nicely move alongside those thinning and widening pulses. Let's push that resonance and engage some hard clipping, just to check out John Mark's other recommendation. It's like kicking in, because it quite literally is, a distortion on the output. So let's take a look at some audio rate modulation. Low saw wave coming in, yellow trace is the output, blue trace is the modulator, plugged into gain so we can normal all the way through. And you can actually see that kind of like downsampled aliasing like shaping of the wave. Looks like it's stepped like a digital waveform. Let's engage some soft clipping, retune, even higher. We'll stop doing FM. And let's actually turn up gain and do some AM. A very drastic effect. It's really quite different to the frequency. Let's stick with AM, and I'll tune it back lower again. So this blue modulator is now pushing this VCA before the tube, before the filter. Here's what it's like after the filter. Still sounds good, but we lose a lot of those edges. And of course the beauty here is you don't have to do AM or FM. Do both at once, or you could even audio rate modulate the resonance. So let's do some positive modulation of resonance. Let's invert the modulation for frequency, bit of gain. Let's hard clip this as well. And let's retune a bit higher. So there's huge scope for audio rate modulation with AM, FM, and audio rate resonance modulation. Let's try and use it in a patch. So here's some audio rate modulation in context. There's none currently happening, and I'm just sequencing this oscillator and volt proactive tracking Vamp. Super rubbery vocal low pass filtering. Now my audio rate modulation first goes into this VCA here, into Curiouser. Turning up its gain, I have set already AM, FM and resonance modulation from this normaling across. And using a VCA to control this. I can use envelopes to envelope in the modulation for modulated modulation or dynamic modulation. Changing the octave that the audio rate modulation is in. Instead of it being constant, this is just opening the VCA fully here. I'm turning down the manual VCA level and turning up the influence of an envelope. So it's injecting this lovely twanginess into AM, FM and audio rate resonance control. Just removing that, let's try it on a bandpass. It's so rubbery, it's like it's wearing a gimp suit. Audio rate modulation. Drop it down an octave. And then making that dynamic, i.e. bringing it in with an envelope. Combining AM and FM I'm finding really interesting. It's certainly something I'll be exploring more of. I hope that provided plenty to sink your teeth into, and that you've gained some patch ideas from the video. If you've got this far, drop a Fang sync in the comments. Check out the multiple bonus exclusive videos with Vamp and gain access to plenty more on patreon.com/DivKid. And I'll see you next time. Bye!